So for today, we're talking about slope and similar triangles. And I just want to remind you, when we look at graph, the slope, we usually think of it as the rise over run. So if you look at this picture here, they started down here and they rise up 2 spaces and then they run over 3 spaces. And it forms that little green triangle. And you can keep going up 2 and over 3, and each time you'll form that same little green triangle. But that's not the only way you can find the slope here. You could go from this point to this point. And in that case, you rise up 6 and over 9. And it makes that orange triangle. Up 6 and over 9. 6 over 9 reduces to the same thing. So the orange triangle and the green triangle are similar triangles. And by definition, similar triangles are 2 triangles that have the same shape but different size. And then likewise, the blue triangle, which is kind of hard to see here, but it's this giant triangle. It's also a similar triangle to the orange and the green because it does have the same shape, just a different size. So let's look at some of these problems. What is the ratio in simplified form of the vertical length to the horizontal length for the red triangle? Okay, so there's a lot of words going on here. First of all, the word ratio means fraction. So we know we're going to have a fraction. And it says we want the vertical length, I'm just going to put VL, the ratio of the vertical length to the horizontal length. And we're looking at the red triangle. Now, the vertical length here, you would count the spaces, 1, 2, 3, 4, 5. And for the horizontal length, you would again count the spaces, 1, 2. And so the vertical length was 5 and the horizontal length was 2. But that was just some really fancy math words in here to basically say find the slope. Because remember, slope means rise over run. And rise does mean the vertical distance. And run means the horizontal length or distance. All right, so using the same triangle, it says how does the slope of the hypotenuse of the red triangle compare to the slope of the hypotenuse of the blue triangle? Well, if we want to find, we just found the slope for the red triangle. We rose 5 and we ran 2. So rise over run was 5 over 2. Let's do the same thing for the blue triangle. Let's see, we rise up 10 and over 4. So for the blue triangle, we rose 10 and we ran 4, which if we reduce it, that's also 5 over 2. I should have color-coded this one red. But the slope of both of those are the exact same. So let's see what our answer choices say. The slope of the hypotenuse of the blue triangle is twice the slope of the hypotenuse of the red triangle. No, the blue triangle is bigger, but that doesn't mean that the slope is bigger. Because remember, slope just means the steepness of a line. And if you look at this line here, it's the same steepness whether you're on the red triangle or the blue triangle. The steepness doesn't change. So the slope of the hypotenuse of the red triangle is steeper than that of the blue? No, it's the same. The slope of the hypotenuse of the 2 triangles are the same? Yes. Or the slope of the hypotenuse of the red triangle is half the slope of the blue triangle? No, that's not true. The steepness is the same for both. Would the hypotenuse of the right triangle with a vertical length of 6 and a horizontal length of 15 have the same slope as the hypotenuse of the blue and red triangles shown in the graph? Okay, well remember we said the rise over run for red was 5 over 2. And then we said the rise over run or the slope for the blue was 10 over 4, which is 5 over 2. They both have the same slope because it's the same steepness. And now we want to know if 6 and 15 would make the same slope. So the vertical length, or the rise, I'm just going to write this again. Slope is rise over run. And rise is the vertical length. And run is the horizontal length. So it says the vertical length of 6. So I'm going to plug that in on top for vertical. And the horizontal length of 15, I'm going to plug that in on the bottom. And I'm going to see if it reduces to 5 over 2. So if I wanted to reduce this, I would divide the top and bottom by 3. And I would get 2 over 5. 2 over 5 is not the same as 5 over 2. In fact, if you graphed 2 over 5, you would go up 2 and over 5. So it would look like this. That is a totally different line than what we have here. So those are not the same. The slope is different. Okay, that's it. Good luck on your quiz today, or quick check or practice or whatever it is. Hope you do well on it.